So the presentation is entitled How to Build Your Own Cloud Encoder with FFmpeg. There's two sections. Section 1 is going to cover the basic FFmpeg commands for encoding. That'll take about 15 to 20 minutes. And I'm Jan Ozer. I'll be talking about that part. And then Phil Moss from RealEyes will be covering how to automate that and how to use it in the cloud. Here's a little bit about us. And who's this presentation for? We're assuming you have plenty of video to transcode. You distribute via one or more adaptive bitrate technologies, Dash and HLS. This is not an entry-level class. We're going to assume you're familiar with concepts like codec and packaging, as well as executing command line and JavaScript. And you also understand some very basics of servers and how to work with them. So just want to let you know that this book is available on Amazon. It's How to Produce Video with FFmpeg in 30 minutes or less. Pretty much everything we're going to cover in this class is in the book. The handout's going to have a lot of the stuff that's in the book, so make your own decision. One of the things that comes with the book is working batch files for everything that we cover. So the book covers everything from simple FFmpeg executables all the way to Bento 4, creating hybrid HEVC HLS or HEVC H.264 HLS presentations. So pretty advanced. It's a $30 book. If you're going to be working with FFmpeg, I think it's a good investment. For the show special, this thing's dangerous. If you buy the book, I'll throw in the PDF for free. A lot of people like having the PDF version. A lot of people like having the hard copy as well. So a couple points about FFmpeg. There's always multiple ways to get things done. I kind of go with whatever works in the most efficient way. We're showing the minimum necessary commands. There's a lot more configuration options that you may want to play with at some point. When you're configuring an FFmpeg command script, the location of the option in most cases doesn't make a difference. And then if you don't choose a configuration option, FFmpeg uses the default. And that's important because sometimes you see like 10 lines FFmpeg commands, and a lot of that stuff is not necessary because if you just leave it out, and you can go with the default, then you're going to save yourself a lot of potential, a lot of stuff that can cause errors just because you have too much information. What I like to do is just boil down to the absolute fewest necessary commands and go with that. And here's the most basic FFmpeg command script. Basically call FFmpeg, list the input file, list the video codec. Yeah, this does not like the mouse. Not do that. Where is? So here we see we're calling the video codec. In this case, it's the X.264 codec. That's the H.264 codec that comes with FFmpeg. So it's input file, here, codec, and output file. Pretty simple. It's a simple script, which means you're going to accept all the FFmpeg defaults. What does that mean? It means all this stuff is going to be decided by the default. In some instances, that's OK. You probably want the high profile for a lot of your encodes. You probably want CABAC enabled. The X.264 preset is very acceptable to use. But if you're encoding for adaptive bitrate encoding, you're creating multiple files. You need a shorter keyframe interval than 250. You may or may not want scene change keyframes at scene change detections. And you almost certainly don't want to use the average bitrate. You probably need some more aggressive form of bitrate control. So if you don't specify any of that in this command string, all these defaults is what you're going to get. And then from an audio perspective, this is what you'll get. So let's dive into the key areas of encoding that you need to worry about with FFmpeg. So the first one we talked about is bitrate control. What we're working with here is a file that's 30 seconds of talking head, 30 seconds of ballet. So it's basically a worst case file from a VBR, CBR perspective. And if we encode with just the bit rate, just the target bit rate, what we see is the data rate varying. Here's the talking head, here's the ballet, here's the talking head, here's the ballet. So we're seeing no real data rate control. Now this can work if you're playing this off of your hard drive, but this may cause issues if you're playing it remotely via streaming. So you may want to use something that's a little bit more controlled. And how do you do that? This is where you have to go to two-pass encoding. And here's the command structure for two-pass encoding. Again, FFmpeg. If you're doing two-pass, you always want to include the Y, because over here you're creating a data file with all the information that FFmpeg collects when it analyzes the file. If you don't have the Y, each time you use it, it's going to say, do I want to overwrite that file? So Y basically tells FFmpeg to overwrite any previous log files. So you always want to include that in the first line. You may not want to include it in the second line. And then everything's explained here, and everything's explained down here for the second line. What we're doing is we're saying, put your data rate at 5 megabits per second in the first line, put it at 5 megabits per second in the second line, and let's see what we get. And we get something that looks pretty similar to what we get with a single pass encode. And this is a program called Bitrate Viewer. If you haven't seen it or you don't have it, it's great for exactly what we're seeing it for, viewing the bit rate of MP4 files encoded with either the MPEG-2 or the H.264 codec. So it's a free tool. If you don't have it, I recommend getting it. So again, in terms of the problem at hand, we're seeing no bitrate control. I would not want to try and stream this file to somebody over a constrained connection. So we have to take it another step further. And this is how you implement bitrate control using FFmpeg. You've got to include the target here. In the second line, you include the target, you include the maximum rate, and you include the buffer size. So what we're saying is target 5 megabits per second and have the maximum bit rate be also 5 megabits per second. And we're saying in terms of the VBB buffer size, keep that at 5 megabits per second as well. What does that look like? Now we're talking. So this is the CBR file. And this file is going to be a lot, the data rates are not, it's a little bit hard to see, but this is 5 megabits here, this is 5 megabits here, so we're very close to the 5 megabit target, which is what you want if you're going to be streaming the file. And once again, you achieve that by specifying the target, the max rate, and the VBB buffer size. The problem with CBR is that you get transient quality issues. So this is a file encoded with CBR. This is a file encoded with VBR. And a lot of producers like avoiding CBR because you come up with just frames that are very, very hard to compress. How do you deal with that in FFmpeg? You give yourself some leeway by defining the maximum rate. So this is how you create data rate constrained VBR with FFmpeg. Same first line. You only specify the target in the first line. And then here you say you can vary the bit rate up to 10 megabits per second, which is 200% constrained VBR. You can vary the data rate by 100% over the 100% target. So this is called 200% constrained VBR. And then we show two alternatives here, 200% constrained, 110% constrained. And let's see what this looks like. So this is 200% constrained VBR here, and it looks just like our initial file, right? It's going up and down with the ballet and the talking head, and then here's the CBR file. So we're seeing a little bit higher quality than CBR, but we still have the deliverability issue that we want to avoid. And this is what our 110% constrained VBR files looks like. So here's the CBR file. here's 110% constrained. The peak data rate here is 5852, here it's 5295. So we're getting slightly higher peaks, but we're going to avoid the transient quality issues. So when I'm encoding for adaptive bitrate technologies, I typically encode using either 110 or 150% constrained VBR. I don't like 200% constrained VBR because I think it can cause problems. And this is how you implement it in FFmpeg. A few ways to affect the keyframe interval. Keyframe interval is the insertion of iframes. And if you do nothing, it's 250. That's the default GOP size. The minimum space between keyframes is 25. That's the default. And the threshold for scene change detection that will insert a keyframe into scene change is 40. So these are all, if you can include all these in your command string, or you can include none of them, you get the same result. But by default, it's important to recognize that FFmpeg will insert keyframes at scene changes. And that can be problematical if you're encoding for adaptive streaming, because you want all those keyframes to be at regular intervals in the segment size. You need a keyframe at the start of every segment. So what do? And this is an example. This is a tool called Telestream Switch. And the really cool thing about this tool is it shows you the keyframes, the B-frames, and the I-frames. So if you use the standard switches, and you can either, again, include these or not include these, you get scene change. You get an I-frame every 250 frames, but if there's a scene change, you get one sooner. Okay, that's if you do nothing. And then for adaptive streaming, most people are using either 2 or 3 frame GOP sizes. And this is an instance where I don't want keyframes at scene changes, because I don't want to mess up with the, I want to keep the iframes consistent in all the different files. And the best way to do that, or one way to do it, is specify the keyframe interval. Typically, this is either going to be 2 or 3 seconds. Specify the keyframe minimum, the same as this, and set the scene change threshold at 0, which basically says, I don't care what happens, I don't want a scene change. And this is how you get a pattern that looks like this. So you get one iframe or one keyframe every 72 frames. And that's what you want for adaptive streaming. What's the problem with this approach? The problem is you lose a little bit of quality if you don't have keyframes at scene changes. So the question is there a way to get keyframes at scene changes and also have regular iframe intervals? And there are with this particular command string. So what we're telling it here is to deliver a keyframe every 72 frames, irrespective of what happens. But we're also saying, keep the minimum keyframe interval of 25, so don't have keyframes within 25 frames of each other. And then if you find a scene change in excess of this threshold, insert a keyframe there. What does this look like? This looks like, you see, these are the regular keyframe intervals at 72 frames, and these are the keyframes inserted at the scene changes. How much quality difference does that make? Very, very, very little. So I typically don't mess with it. I typically go with just this approach because it's simplest. But if you want to achieve this and get the little bit better quality, this is how you would do it. Resolution, there's again a few ways to do this. You can do it, the simple way to do it, you use this if the aspect ratio is the same for your output footage as with your input footage. So if you're going from 1080p down to 720p to 360p and the aspect ratio is the same, you can just use the -S switch. If you're worried about, if you're going to a different aspect ratio, then you want to use this switch here. Frame rate is typically a simple one, -R and then the frame rate. This gets a lot more complicated when you're doing things like switching from 30 frames per second to 60 or from 60 to 30, but for most instances, this will work for encoding. In terms of profiles and levels, if you do nothing, FFmpeg will insert the high profile. If you need the baseline or if you need the main, you include the profile :V switch and then list the profile that you want to support. If you need to insert the level into the metadata of the file, you basically say level, number, and then list the level here. In my experience, this doesn't constrain the encoding. This just includes the level in the metadata. Is that consistent with what you're saying, or have you guys messed with this at all?
I think it's pretty consistent.
Sorry?
I'd say it's pretty consistent.
Okay. And basically what that means is if you're targeting mobile devices that only meet a certain level, you can't put the level in and expect FFmpeg to encode to that level. You have to specify the parameters that encode to that level and then include this so it's in the metadata. If you want to include the preset, if you do nothing from a preset perspective, and this is x.264, if you do nothing, the default is medium, and FFmpeg will use the medium preset. In most instances, the medium preset is going to give you a very good balance of quality and encoding speed, so that's not a bad way to go. If you want to tune your footage, there's a number of tunes in the FFmpeg x.264 implementation. You've got animation, film, still images, PSNR, SSIM. If you want to tune for any reason, it's dash tune, no space. That's an error, same here. And then just list the tuning that you want to use. And then this is from this website, just explains what switches, what parameters are in each preset. This is what you get by default. If you want to change any of these in any way, you can either change the preset or you can list these specifically. And I typically just go with the preset and keep things simple. And then to fill in some gaps on the audio, if you do nothing, you'll pretty much get 128 kilobits per second AAC audio if you're encoding H.264. If it goes in as stereo, it'll come out as stereo. If it goes in at 44, it'll come out at 44. If you want to control these, you just have to list these individual parameters. And they need to be in both the first pass and the second pass. And a couple things about multipass encoding. For ABR streams, in a lot of instances, you can use the first pass more than once. So if you're encoding a bunch of files, your entire encoding ladder, you can use the same first pass so long as you don't change the frame rate, the keyframe interval, or the profile. So you can have one first pass and then multiple second passes, which saves a lot of encoding time. Do you guys do that? Do you use one first pass more than once?
Yeah, sometimes.
Okay.
Yeah.
And then which configuration options have to be in the first pass? The frame settings, B-frame, keyframe, target data rate. And again, some say the audio settings, although my tests haven't proven that to be true. I typically put them in if I'm working with a client because I've seen references that say you have to include those. And FFmpeg does a nice job producing media playlists, but can't create the master playlist. And if you want to package your video files and create the media playlist, this is the command structure you would use. You list the format, the segment length, how many segments you want in the media segment playlist, and then whether you want a single file where you retrieve byte range requests or whether you want multiple transport stream files. In this case, I'm asking for a single file to get byte range requests. And then here's pass 1 with 3 second passes producing a 1080p, 720p at a high data rate and 720p at a minimum data rate. So this is how you would implement, and this would produce both the MP4 files and the media manifest files. Cvc encoding is pretty much the same thing. The only thing is there are a lot of options that need to be behind the x.265-params. If you don't include options like these behind this, if you just include them the way you do it for x.264, you won't get an error, but they won't be implemented the way you want them implemented. So you really need to be, if you're looking at X.265, if you're encoding for HEVC, you can't do what you do for H.264. So stop, go find the documents. It's pretty well documented in there, but you have to use this. And again, you won't get an error. The first version of a book I wrote 2 years ago, I messed this up, and I didn't know it for like 3 or 4 months. And then I had a consulting project where things weren't coming out, and then I sent the file to the guy, and he said, well, of course your files look better. You don't have any data rate control. You don't have any keyframe intervals. So everything I thought was being implemented wasn't being implemented, and because there were no error messages. It just wasn't done. So if you're looking at X.265, remember this page. And now I'm going to leave it for Phil to do Bento 4 and the automation piece. You want to use this, or are you going to use your?
I'll just bring mine.
OK.
Got an application to run.
Pardon? Yeah, I can pull. Yeah. It's down here.
It just looks full. I'll be all right. The computer's not what it used to be. Yeah. All right, so I'm going to talk a little bit about what I do usually on a daily basis, which is running cloud encoding, workflows, any sort of HLS packaging, MP4 encoding, and some of the tools that I like to use to manage that. So Jan was talking about FFmpeg, the way to condition your streams, get them at the proper bit rate, get them in the proper codec, keyframe interval, all of that. So I'm going to show you how to package efficiently in the cloud or in your own application. So one of my favorite applications is called Bento 4. It was new a couple of years ago. Well, it wasn't really new, but it was not a lot of people knew about it a couple of years ago when I first started talking about it. Now it's pretty much a standard. A lot of people are using it. So what can I do with it? I can do HLS generation, including master manifests, stream level manifests. You can do TS files. You can do fragmented MP4. You can do MP4 to fragmented MP4 conversion. You can do dash. You can do multiplexing of not just 264, but 265 and AAC streams. You can do DRM, all those different codecs. You can do dual generation, CMAF generation for dash and HLS at the same time. You can do atom box editing, viewing, codec information, all of that within this one tool. It gives you several binaries that you can do a lot of really cool things with. So Jan was talking about FFmpeg, which is going to be more of a broad spectrum tool. You can do pretty much everything with it. It's a lot of people contributing on it. It's an open source application. Pretty much anything that you want to do, video, audio, you can do with FFmpeg. Bento 4 is going to be focused more on just your MP4s and how you can manipulate an MP4 without re-encoding it. So you can look at all the information inside of it. You can segment it into HLS dash, or you can turn it into a fragmented MP4. So it gives you a bunch of HLS options. We'll be talking more specifically about HLS today. You can create the master manifests. You can do a single file output with byte range requests. You can get iframe only manifests. You can do AES encryption, whether that's sample AES or AES 128. You can do DRM, all sorts of different DRM. You can do audio stream sidecar. You can do subtitle caption sidecar. And you can do fragmented MP4. So let's say you have 3 conditioned streams. Jan just gave me a bunch of MP4s that he conditioned with FFmpeg. It's got a nice keyframe interval. It's got its bit rate within 110% of its max interval, max bit rate within 110%. You can take those 3 or 4 or 5, and you can run it through MP4 HLS. And you can give it a segment duration, and the segment duration is going to cut at your keyframes. So if you give it 3 inputs, say 7,000K, 5,000K, and 3,500K, and you just run it through this, it's going to output 1 master manifest pointing to 3 stream level manifests. So you basically have a multi-bit rate HLS package right there. And it'll give you iframe M308s as well, which is pretty cool. If you want to do multiple audio streams, you can handle that as well. You can specify the language with that syntax. Let's see. Right here, language ES, that's Spanish, España. And then you can do M4A. You can give it a video MP4, Spanish M4A. You can give it EN, English M4A as well, and that'll output different audio M308s for your different AAC fragments. You do the same thing with subtitles. English right here, so you format of web VTT, language is EN, and then you would output with English.vtt, and then a video of video MP4. So you're going to get your master M308, your stream M308, and then you're going to get a caption M308 with segmented VTT files. You can also do encryption, like I was talking about. So right here, I have an example of AES 128. So you can put in your encryption mode, AES 128, your encryption key, and then your encryption URL, so where your manifest should be calling to grab that key, pull it down, and decrypt your segments. So this is going to output all your HLS assets that we were talking about before. They're encrypted with AES 128, and then an encryption URL on the manifest. So you can also do dual HLS and dash from a fragmented MP4. This is my favorite part about this, is because a lot of people are moving towards CMAF, which is you have a single fragmented MP4 video, and you can access that video with either a dash manifest or an HLS manifest. So you can reduce your storage costs right there by just having a single asset that you can use for either dash or HLS. So you can handle that with Bento using the binary called MP4 fragment. So you can give it an input MP4, and it'll output a fragmented MP4 of that exact video. And then you can run it through MP4 dash, which is another binary with Bento. And if you put the dash HLS right here, parameter, no split's going to keep it as a fragmented MP4. It's not going to split it into M4S files, or you can leave that off if you do want segmented rather than byte range. And then you give it the MP4, and it'll output a master M308, an audio M308, because it'll demux out the audio from the input MP4. It'll give you a video M308, but it'll also give you a stream MPD, which is a dash manifest. So it'll all be running off of the same asset. So I can give you an example of this, actually. So let's see. I can't actually see that. Okay. All right. So let's say I have a 264 stream right here. Tears of Steel teaser, it's about 60 seconds. And then I want to turn it into a fragmented MP4. I can do this through the command line with MP4 fragment, which is a Bento 4 tool. Cool, so that's done. It's fragmented the MP4. And then if I want to run it through Dash, I have an HEVC fragment and an AVC fragment. And then it's going to create HLS and Dash assets for me. And that's done. So if I want to take a look at that, do that right here. So I have a master M308. Give me my audio, English. It's my default, and then it gives a URI to the audio M308. I have two videos. One is AVC, one is HEVC. And then it says that I'm using this audio right here. If people are familiar with HLS assets, it's just outputting everything that you would need it. It automatically detects the average bandwidth, the codecs, and the resolution. And then it outputs into two different M308s, and then it gives you two different iframe M308s as well. So it did all of that in, what, a quarter of a second, which is pretty nice. Okay, and then it gives you your fragmented MP4 right here. There's my AVC and my HEVC. This is my stream.m308, my stream.mpd. So this is my Dash manifest output running off of the same fragmented MP4. So you can do the same thing with a single bit rate. You can do it with however many bit rates that you want. So some other info about Bento. It'll only segment at an iframe. It'll create HLS assets faster than FFmpeg. It used to be faster than Shaka. Shaka is actually pretty good now. I like it a lot. It'll gather its metadata, like I was saying, while segmenting. So it'll give you codecs, average bandwidth, and resolution automatically. And it'll give you a full set of Dash and metadata options. You can find the libraries over at bento4.com. I don't work for them. I just like them. I also like to use Shaka Packager. When I first started talking about different packaging solutions, Shaka was actually really slow. I think they were focusing more on the Shaka player, but Google is Google, and they've made a lot of improvements. It makes it really simple to demux audio and captions. It gives you simple DRM integration. And it's the only open source packager that I can find that does add queues, server-side add insertion. You can create queue points in your assets really simply. So I really like them for that. So let's say you have a 2-second keyframe interval and you have 6-second segments. You want to throw an add in at 8 seconds and 24 seconds or 26 seconds. You can actually specify, hey, I want an add queue at 8 and 26. And it'll segment. It'll do your 6-second segments until it reaches that queue spot, and it'll actually resegment there so that you can go into a queue nicely and come out of it all synced up with your audio and video. So I use them when I need to use add queues. An example of using Shaka, it's a little bit more complex than running Bento, so I like Bento for its simplicity and gives you pretty much everything you need. But when I need to run add queues, I'm going to be using Shaka. And you can do this with an input MP4 for your audio, an input MP4 for your video, and then you can do encryption with Widevine, whatever DRM you want. You give it URL, an AES signing key, an initialization vector, and then you give it your master manifest output. And it's going to handle pretty much everything that I just talked about with Bento. All right. So the main thing that I wanted to talk about was not just other people's packagers, but I want to talk about how to create an entire solution for yourself in the cloud or in an application. So you're going to have to choose a cloud to be able to do cloud encoding. So you have multiple options: AWS, Azure, Rackspace, SoftLayer. You got Google Cloud. You can do it on-prem, or some kind of hybrid between on-prem and in the cloud. And to size your server, you're going to be thinking about what are your bit rates, what's the size of your assets, how many are you going to be doing concurrently. Are you going to be doing adaptive bit rate? Are you going to be doing multiple for a single stream? And same thing with VOD. Are you transcoding, or are you just segmenting? Are you changing the bit rate of your asset, or are you just parsing it out into HLS assets? These are all things that you need to think about when sizing your server, because encoding is going to take a lot of CPU, and then segmenting into HLS is not. It's quick. It's a stream copy. So in our experience at RealEyes, we've found M3 large to be pretty cost-effective, decently performant, especially if you're going to be doing a lot of segmenting. It's not going to have GPU acceleration or anything, so it's going to be all software encoding. And with Azure, we've made the same decision. Well, we sized it based on AWS and found a similar match over there. And we like to use Red Hat Linux because it makes all of these applications much more simple. So to get started with EC2 and Azure, most people are pretty aware of these two virtual machines. But here are some links if you need to grab them. So FFmpeg also has the ability to offload to GPU, and NVIDIA has actually made some huge changes here recently. So you can do an NV encode and decode on FFmpeg, and I know that both Azure and AWS have support for GPU acceleration. So that's going to be a different codec. You can output it into a 264 container, but it's going to use GPU acceleration, and it's going to be faster. It actually ends up looking a little bit different, which is something that I talked about yesterday. So this is with a 265 boost from Intel Xeon Scalable processor family. So this is software encoding. And there's a 67% average per core gain on encoding using the HEVC main profile. 50% average gain with main 10 profile across different presets. And something that Jan was talking about is the difference between your profiles, main and main 10. With HEVC, a lot are moving towards main 10 at the moment. So to create a cloud encoder, I like to use FFmpeg, I like to use Bento, I like to use Shaka. ImageMagick, if you're going to use sprite sheets and thumbnails instead of trick play from an iframe manifest. You can use Node. You can use, personally, I like to use Golang in my applications. I know that there's a lot of Node. JavaScript's very accessible, so that's something that we've created an application in for you today. MongoDB, it's really nice. You just need flat metadata in case your encode or your entire workflow gets stopped. You have your state and you can restart it. It's just flat data. And then Cloud Provider SDK. So the AWS SDK, you can use child spawn with FFmpeg Bento 4. And to get an FFmpeg build, you can get a static build from ffmpeg.org. Or you can build it yourself with Make. And they have instructions on how to do that on their GitHub. All right, so your cloud workflow. Let's make it happen. You need a good architecture. It's going to be similar to AWS Simple Workflow Service as far as you're going to have different microservices that do different things, and a workflow, which is an end-to-end execution. It's going to happen in order, because if you think about an entire cloud encoding solution, you have to grab your asset, upload it to where you're going to be encoding it. Then you have to encode it into its directory, and then you need to upload it to where you want to be able to access it, and then you need to clean up your server. So all of these things need to happen sequentially. So the architecture that I like to use is more of a workflow architecture, using steps, tasks, and then adapters. So your business logic can be very ambiguous. Let's say you want to change between Bento 4 and Shaka. and you want to do that mid-project. You have your business logic saying, this is how I'm going to encode, and then you have your third-party adapters saying, this is the way I'm going to encode, and you can mix and match those. You can switch them out. Makes development really easy. So if anybody's familiar with clean architecture, I think that works really well when you're trying to choose between third-party applications. Try to leverage any performance enhancements. Upload and download is going to be more than anything that's going to be your bottleneck because you have limited bandwidth. So harness anything you can. I know Net Storage with Akamai has the ability to do rsync. They also have the ability to do Aspera, anything like that. Harness that if you can get it. Otherwise, AWS has multi-part upload. Azure has streaming put to a block blob. And you can also do an initial content migration using Snowball or import-export service, which is where one of these services gives you a big old hard drive, you put everything on it, and you mail it, which can actually be faster than doing it over the wire if you have a lot of content. You're also going to need a queue. It's pretty straightforward data structure, first in, first out. The reason why you're going to want to do this is because you can only encode so much at once. Your computer, the CPU is going to want to use 100% for every single encode, 100% of your CPU available. So let's say you do 2 encodes. Each one is going to try and tag 100% of your CPU, but neither one can get it. So there's a sweet spot for how many encodes you can do on a single machine. And it takes time. So you're going to have a queue, and you're going to have a concurrency limit. So first into your queue, first out, and you can take so many without overloading your server, whether that be with your uploads, your downloads, or your encoding. All right, so we have a small demo at github.com/realize-media/demo encoder. And this is something that I built just a small example of how we do things. I think I built it in a day, and it's very simple as far as what it can do, but it's a good example of how to build a workflow from first step to last step, and that is creating your assets, uploading them, encoding them, and deleting them off of your server to make space. And I can actually show you an example of that. Five minutes? Okay. So I'm not an artist, so this is a bad little front end here. I just threw in some random bit rates. You can choose your codec. Let's say it's 264. You want your segment size at 6. Let's output to M3U8. Let's just do stream copy because we don't have a lot of time. So if I choose a file, TOS teaser, and then let's submit it. Okay, so it just encoded. Right. So what that did was it downloaded, it took my video from my computer, and then, oh, this is just audio, isn't it? So it took the video from my computer, and then encoded it, and then uploaded it to S3, gave me a URL, and then deleted it. And then we have that example for you on our GitHub. If anybody who just wants to steal some code, go for it. Scaling, we already talked about that a little bit. How many can you do at once? You're going to want to scale with EC2 or Docker, preferably both. Do you want a bigger instance or more instances? And we prefer to use more so that you can scale as needed and scale down as needed. And then using a load balancer. We use Docker Kubernetes for our scaling, and it'll implement auto-scaling for you. And I just showed you the demo encoder. So are there any questions about how to build a cloud encoder? Uses FFmpeg, Bento, Shaka, how to put that in the cloud. Any questions about that?
You use Fluent FFmpeg for that?
Yeah, with Node, I would use Fluent. If you can also roll your own using like child spawn, so you can run it as a command line application from your application. Yeah, you can run that from your application as you can spawn it as a different thread and run it as a command line up. Yeah, but yeah, I do use Fluent a lot.
And one thing too, you said that you use the same first pass there, or I can't say that. Is that something you can run multiples in parallel, or just that you can modularize? And if you could speak about modularizing your FFmpeg.
Yeah. Yeah, so you can definitely run FFmpeg concurrently. So are you talking about like doing two different assets at the same time?
Well, you can recycle that first pass if it's the same, and then you have your unique second pass for all the different files where that's somehow a benefit. And I assumed it was some, because you can run it parallel and modularize that.
Yeah, well, your first pass is going to always have to happen before your second, but you can definitely modularize your all of your passes in code, right? Is that what you're asking?
Yeah, it's a little bit back to this.
Okay.
In this case, you have to say multiple runs of first pass. You run first pass once, you say processing seconds. This way I understand.
I mean, as long as the log file exists, I mean, I guess you could copy the log file to multiple folders and access it with different instances of FFmpeg that way for the second pass. Is that kind of what you're asking?
Well, I wasn't really clear why you were saying it was somehow an advantage that you could recycle that first one.
Because otherwise you'd have to run, I mean, first pass is not as long as your second pass, but it is time consuming. So if you're encoding 10 files in your encoding ladder, if you don't use the same first pass, you'd have to run the first pass for each one. So you're saving 20–30% of encoding time and encoding costs if you use the same, if you use that first pass for multiple encodes.
But then you have to think about storage space at the same time. So if you're doing a lot at the same time, when do you need to clean up your assets from your server? Because you
don't want to just balloon them during the thing and
right.
you're going to clean it up.
Right. So it's a balance between storage space and encoding time. Yep. Okay.
Repeat the question.
So the question is 3 different packagers, MP4 Box, Shaka, and Bento. And you wanted to know how they compare. I don't have a ton of experience with MP4 Box. I've used it a little bit. I've always preferred Bento when I need something very simple and fast. They have pretty good support. They're very active. They're open source. They have a lot of people contributing to them. And for anything that needs to happen fast and simply, I'm always going to use Bento. For production, I'm going to probably move towards Shaka. It's backed by Google. It's more immediate support, and it's a little bit more robust. And then did you have a quick question? We need to wrap it up.
I was for John, you were talking about adaptive encoding scene change threshold.
Yes.
The same scene change threshold, again, between resolutions, like keyframes will not line up, right?
That's your concern when you don't have those lining up. Well, let me take a question after. Let's let everybody go, and you can ask me.
Will the second presentation be made available offline?
Yes.
Yeah. Yes.
So what are you going to do? Why don't you email me the PDF, and I'll post it next to mine.
Okay.
So look at the
Jen will
same
get-
URL, and we'll get that to you. Okay, thanks for coming.